Okay, so this video has sound. Make sure you can hear it. I always put this sign up to tell people that if they're looking at a screen and they just see this sign, they know what to do. We are in chapter 1 of the Geometry Study Guide. I also call the note-taking guide. And we are on page 8. This lesson is covering both 1-2-1 and 1-2-2. That's chapter 1, section 2, parts 1 and 2. And I won't actually be talking about every single definition and every single example here. I'm just going to hit the key components. So, postulates, axioms, and theorems are basically rules that we can apply all the time in math and science. A coordinate is basically just a position that is indicated mathematically by two numbers. And distance is the big idea here. We're going to be learning something called the segment addition postulate. And basically it says that if you have two smaller distances that add up to a whole, that's basically what it is. The two smaller pieces, when you add them up, should give you the entire distance across a certain length. So distance, I suppose you could simply just say that it's a numerical measure of length between two positions. So I'm going to define that here. Okay. So, as I was saying, the main postulate for 1-2-1 is called the segment addition postulate, and that basically says that if you find the distance from A to B and add that to the distance from B to C, you will get the complete distance from A all the way over to C. So essentially, AB plus BC equals AC. Now, I want to state that this is actually something that you'll be tested on or quizzed on, and that is that the way that we wrote these distances is very specific. So you see how we wrote AB, and that's it? It was just AB to represent the distance from A to B. It's really important that you know that when you're writing down simply, two letters together like AB, two letters together with no other symbols on top, that is an indication of length. Okay. Now, you may remember back in the first section of chapter 1, we talked a lot about different figures. Specifically, we talked about lines, planes, line segments, and rays. Now, remember when we talked about how to write down the name of a line? We said, well, you use 2 points on the line and then you draw a picture of the line on top. So you see how that's different than this? This is just 2 letters with no symbols on top, whereas if you want to talk about the name of a line, you'd have to write it like that. Or a line segment, you'd have to write it like that with this symbol on top. Or a ray, you'd have to write it with that symbol on top. So you see that these 3 names, lines, line segments, and rays, are written with symbols on top. But when there's no symbol on top, it simply is talking about how long something is between A and B positions. Now, let's do a few examples where we can apply the addition postulate. The first one is example number 2. It says there's a road trip and there are a starting point, a rest area, and a destination that are at 3 different positions that form a straight line. And so from the starting point to the rest area, that's 64 miles. I don't know if you can see it very well, so I'm going to write it bigger. And then from the rest area to the final destination, this length of road right here, it says 87 miles. And again, I'll write that bigger. So it says find the distance from the starting point to the final destination. Well, obviously that whole length, you can simply add the length of road here to the length of road in the lower portion. So we would simply add 64 plus 87, and that will give us 151 miles. Total distance starting point to destination. Now, sometimes they're not going to ask it in the exact same way, but we can use the same concept. For example, this distance right here from J to K is 15 units, but the entire distance all the way across from J all the way to L is 38 units. So what they want to know is, how far is it from K to L? Well, certainly we know that JK, this segment here, if we add that to KL, two smaller segments will add up to a grand total of the full length from J to L. So you could say that the first distance, 15, plus the second distance from K to L will give you a grand total of 38 from J to L. So one way to do this would be to solve it like an equation. We would subtract 15 on both sides, and so the distance from K to L would be 23. That's the more formal way to think about it. If you just looked at this question and said, hey, you take 38, you subtract 15, bam, you got 23, that's okay too. You're just thinking about it in terms of just what the picture looks like. You're just thinking of it in terms of spatial relationships. Total, part, find the other part. The example down here, they want you to find QS. They have two questions. Sometimes our prompts have two things that they want us to find. Here's Q, and here's S. So to find the distance from Q to S, the distance here from Q to R is 31 units, and the distance here from R to S is 30 units. So QS is simply adding the two pieces together, 31 plus 30, which gives you 61. And then PQ, we're going to ignore this portion. We can see that from P all the way over to R is 55, but then this little part is 31. So PQ, we can simply say that this complete distance from here to here is 55. That's what this says right here, 55. And the part of it over here is 31. So to find the other part, we just subtract 55 minus 31. And we get 24. Okay, now I'm going to do one more example, but I'm going to do it in the notes pages. So you'll see over here in the very back part of your packet, this is your note-taking packet study guide for chapter 1, that in the back there's some extra pages labeled other notes, and I'm going to do an example back here. It's just some space where you can write any miscellaneous things that'll help you learn the math we're working on. Okay. So here's the example. That's my last example for this lesson. If you have a line segment and the full length across, we're going to call that 4x. Okay? But the line segment is cut into pieces. So this is position A, this is position B, and this is position C. From A to B, that's 20 units. And from B to C, we're going to give that a name. We're going to call that 2x minus 6. Okay. So what I know is that the full length right here, 4x, from A all the way to B, or excuse me, A to C, can also be written as just the sum of the two pieces, AB plus BC. So, using their names that they've been given in the diagram, the full length, 4x, is the same as adding the two pieces together, 20 plus 2x minus 6. So, this can help us solve questions like, for example, if they want us to find the length from A to C. Well, first we'll need to figure out what x is, and then once we know what x is, we'll know the distance from A to C because we can multiply that value by 4 and find our answer. So using this addition postulate for segments, we can create an equation with one variable, that's the x, that means there's only one letter in this equation, and that means we can solve for it. So what I'm going to do is I'm going to add the 20 and the negative 6 and get 14. Then I'm going to subtract 2x on both sides. 4x minus 2x is 2x. These cancel and you just get 14. And then if I divide both sides by 2, x equals 7. Now, a common mistake that students make is they think that that's their final answer. But if you really read the question carefully, go back to what we've been directed to do, it doesn't say find x, does it? It says find the distance from A to C. So, since the distance from A to C is represented by this name here, 4x, I'm going to say that AC equals 4x, 4 times x. Now that we know what x is, it's 7, we know that that would be 4 times 7, or 28. So our final answer is that AC equals 28, not x equals 7. And that's it, folks. That's the lesson for 1.2.1 and 1.2.2.